because I'm dividing y by that. So I'm multiplying, in essence, I'm multiplying y times xy over x squared plus y squared. You guys understand it, guys? It's a bit like if I have a number, so there's my y, say 3, and there I've got a number there, 4 over, say, 4 over 6. So then you'll say 3 times 6 over 4, okay? And it's 18 over 4, which is equal to 9 over 2. And so it's like you're saying 3 divided by 2/3, it's 9 over 2, okay? So it's the same thing that's happening here. If you work with numbers, this is how you're going to do it. Of course, these x and y's represent numbers, but just more general, okay? So, yeah. So without further ado, I can now say, okay, my LCD here, the denominator of x is 1. So my LCD here, well, it's x squared plus y squared, right? Then I divide x in there. I need some space here, but let me see if I can force space here. X times x squared plus y squared minus, and here I can multiply these out here. I've got xy squared. Okay, xy squared. So let me continue on the far left. And let me sort out what's happening here. Let me multiply these out here. When I multiply those out, well, I've got x cubed plus xy squared minus xy squared all divided by x squared plus y squared. And you can see these like terms cancel. Then I'm left with a much more simplified fractional expression. There's, guys. Okay, let's do problem number 73 from the same kind of exercises, okay? From the same section, problem 73 now. It's on page 42 also. And here they say simplify the fractional expressions like these arise in calculus. So this is a pre-calculus course. So once you do the calculus course, you'll find these kind of expressions arising that I'm going to write down now. So you have to simplify something like this. So it's the square root of 1 plus, then I've got x cubed minus 1 over 4x cubed. And these are all squared inside here, all squared. Right, just do this nicer here. All squared inside. Okay. Yeah, so I've got 1 plus open bracket x cubed minus 1 over 4x cubed, all squared, okay? So we need to simplify that expression. Right, so we can approach it a number of ways. What I would propose in this case is first to deal with whatever's happening inside this bracket. I would propose first dealing with those two terms inside the bracket there, okay? So I would leave the 1 unscathed. I would just proceed. Then now I'm inside the bracket. So this is what I would do. Inside the bracket, there's my squared. So I'll take the LCD there, which is 4x cubed. All right, 4x cubed. And this is x cubed over 1. So 1 goes into 4x cubed times, and 4x cubed times x cubed. Using your laws of exponents, it's 4x to the 6. Because you're multiplying x cubed with x cubed, and you add the exponents, the bases are the same, and you multiply by 4. And then you've got minus 1. Okay, that's what you have there. Right. So, so that's the scenario that we have currently. There are a number of things you can do in this instance. But I would probably do the following. You can multiply all those things out. Or at this stage, you can maybe leave the numerator inside there, multiply out the denominator, and then combine this one with those terms, okay? So there's a number of things you can do. One of the things is this, which you can do. I want you to look at this expression here. I want you to look at something like this. If I say to x squared minus y squared, I talk about something like this, right? You will write this, if you want to factorize this, you can say x minus y, x plus y, okay? And if you look at the numerator inside the bracket, it's also the difference between two squares. Remember, we call this the difference between two squares. Inside there, you'll also see the difference between two squares there. So this is 2x cubed minus 1 squared, 2x cubed squared minus 1 squared. You can look at it like that if you want to. That's just one approach, okay? On the other end, you can still square things here, because if you square this, it's 16x to the 12. You can multiply all that out. That's also another way of doing it. So let me do the following. And I hope this is the simplest approach I'm taking. So what I can do is I can do this. I can say 1 plus, then I'm going to use that difference between two squares now, okay? And I can say, okay, 2x cubed minus 1 times 2x cubed plus 1. So I've just factorized that expression, this one here in the numerator. I factorize it because I recognize it as the difference between two squares. If you multiply this out, the terms, the factors in the bracket, in the square brackets, you'll get 4x to the 6 minus 1, okay? So I hope that will give us a nice, and be able to cancel it. And then we divide it by 4x cubed again, right? So that we have that kind of scenario now. I may have to revert back to that 4x to the 6 minus 1, but let's see what happens here. So, but everything is in squares there, so that's okay. So if I look at my denominator there, if I look at my denominator, well, I can maybe multiply it out, keep these ones on top. So on top, I would have 2x cubed minus 1, 2x cubed plus 1, and that's all squared. All squared. And in the denominator, I can also square the denominator here, which is just 16x to the 6. Remember, guys, if you say 4x cubed and you square it, well, it's 4 times 4 is 16. And using your laws of exponents, it's x to the 6 there, okay? That's what I have. So here I just multiply 3 times 2. It must give me 6 here. Sorry for that, guys. It's x to the 6 there. And then what I can do then is to combine these, that 1 and get it into that fraction. So if I proceed now, I can say, okay, let me get my LCD now. My LCD now is 16x to the 6. And if I put my 1 in there, well, 1 divides in there 16x to the 6 times, right? Plus, then I've got this here. And I probably have to revert back to, instead of writing this in this as a product of two factors, I may just have to go back and write it back in the form that it was, 4x to the 6 minus 4. So because I can see a cancellation happening. So what I would propose, guys, is rather, because of the cancellation, you don't need to do all this really, yeah? I could have just left it in that form, because I was hoping there might come up some other cancellation, hence I factorized. Now I realize when I multiply it out, I can have a better cancellation, so that's okay. So I revert back to keeping this 4x to the 6 minus 1, I keep it. And this here also, I would just say 4x. And then I'll square everything there, because I can see now after I made it 1, it's much simpler. So I would rather keep this and say 4x to the 6 minus 1. When I square that, you guys know how to handle the squares. So now what I'm going to do now, I'm going to multiply this out here. This here, I'm going to multiply it out. It's squared. You guys remember, if I say to a minus b squared, it's just a squared minus 2ab plus b squared. So I'm going to do the same there. There the a is 4x to the 6 and the b is 1. Okay, so I'm going to do the same kind of multiplication with the numerator 4x to the 6 minus 1. Okay, so this is what I propose now. So because I can see some cancellations probably happening as I proceed. Okay, so not belaboring this too much. Let's see. Okay. So I'm multiplying this out now. Yeah, I'm squaring this now. Okay, so currently I have to write it here. So 4x to the 6 times 4x to the 6 is 16x to the 12. And then I say 2, this 2 here, times 4x to the 6 times minus 1 gives me minus 8x to the 6. And then negative 1 times negative 1 is plus 1. And then I see a cancellation occurring. I can see again some, well, not necessarily all of it, but 16x to the 6 minus 8x to the 6. Well, that gives me, let me just write my stuff to the far left here, guys. Right to the far left. So now I've got some like terms occurring there. With some like terms occurring this year and this year. So that I've got 8x to the 6, 8x to the 6, and I've got 16x to the 12. Normally with like the terms with a greater power, we like to write it first. So we would write 16x to the 12 and plus 8x to the 6 plus 1. Okay. And all that is divided by 16x to the 6. Right. Right. Now, what we need to look out for is the following now. You need to look out for something like this. We would like to factorize the numerator now, okay? We'd like to factorize the numerator, and you guys, from your earlier experience with factorization, would recognize this. You would recognize how to write the following. That's that. Right. If you guys multiply this out here inside this bracket here, you will get this numerator under the cert there. 4x to the 6 times 4x to the 6 is 16x to the 12. 2 times 1 times 4x to the 6 gives you 8x to the 6. And 1 times 1 gives you 1. Okay? That's what you're left with. So that ultimately your final answer is now, they ask for the square root of that. Square root of that. Well, you raise everything to a half here, meaning you must write this as follows now. So I'm just going to revert back to exponents just to show you what happens. And that's squared. It's squared. And this one here, 16x to the 6. And now you can write that third form, you can write it in exponential form and use some law of exponents there. And then you will see that that 2 cancels with that 2. And the 2 half times 6 gives you 3. And then you will also recognize now that you can write this as follows. 4x to the 6, you took the square root of that, plus 1. And now you must still multiply the half by this here. You must take the square root of 16, which is 4. And the square root of x to the 6 is x cubed. And there's your final answer, guys. Okay. That's the simplified answer. Okay. Right. Are there any questions there, guys? Of course, someone would say, but where's the negative square root? Well, I just assume here that ask for the positive square root. One can say plus or minus this term here. Okay. So that's the simplified version of it, guys. Okay. Any questions there, guys? So they say that this kind of expression, the original expression that I wrote down here, it arises frequently in calculus problems, this one. Okay. And look how we've reduced it. And you would see, guys, initially I tried some factorization here, but I realized it wouldn't take me anywhere. Remember, yeah, I tried to write it as 2x cubed minus 1 times 2x cubed plus 1. Then I had to revert back to this because I realize now there's a 16x to the 6 arising, and some cancellation will happen probably, which did occur. So this relatively complicated expression here then reduces to the simplified expression here. You saw what I tried initially there, guys. I tried to factorize, but I realized that's not going to help me much. Usually it helps you with cancellations. And then I had to revert back again to the original, the denominator, the numerator I got in the second step, this numerator. I had to go back to it again, okay? So I tried to express it as the difference between two squares, hoping for some cancellation, realized it won't happen, reverted back to that, reverted to the second steps expression of the numerator. And then ultimately, I just rewrote this third form in exponential form like that. And then made sure that I do the necessary cancellations using my laws of exponents. So here, a half times 6 gives me 3 in the denominator here. And then 16 to the exponent a half, well, that's 4 squared to the half gives me 4. Okay. The square root of 16 is 4, well, plus or minus 4, but for now, let's stick to the positive square roots, unless they say they allow for negative square roots.
So, sorry to take you back. That's where I was just lost somewhere where you've got 8x to the power of 6 plus 1. So I don't know, how did you get that?
Okay. No, it's fine. Let me. So it's this step here, no? It's this step here?
Yes.
Okay, no problem. Let me raise that and work through it again. Let me raise this whole thing here and go back to it again then, okay, to show you how I get that. Okay? No problem. Okay. Let me raise this step for you. So let me do this. And then go back there. You remember what I did, okay? I'll show you now stepwise again how I got to that. So what I realized when I wanted to do some factorization, I said, well, there's a cancellation that will happen, so let me go to that. So what I did was this, okay? So if you look at 4x to the 6 minus 1 squared, right? 4x to the 6 minus 1 squared that we had here. So what I first did was the following. I said, okay, I first asked for the lowest common denominator of 1 and 16x to the 6, and I get 16x to the 6, right? Now I say 1 divides in there 16x to the 6 times. And then, well, this here is already over 16x to the 6, so there's no need for me to still do whatever. I just keep it like that, okay? I just say plus. But now, so I'm going to write down 4x to the 6 minus 1 all squared, right? But now I'll multiply it out first. So what I was going to do now, I was going to write it like this, 4x to the 6 minus 1 squared. But I said, okay, let me just multiply it out. It's like if I say to you a minus b squared. You will say a squared minus 2ab plus b squared. You will say this equal to a squared minus 2ab plus b squared. So I'm doing exactly the same thing here with 4x to the 6 minus 1. So this is what I am doing there. I'm saying 4x to the 6 times 4x to the 6 gives me 16x to the 12. Okay, that's what I'm saying there. So I square this one. Like I said, a times a, I get a squared. So 4x to the 6 times 4x to the 6. Well, if I do it here, down here, let me just say in a little block here, 4x to the 6 times 4x to the 6. Because I'm looking at it squared here. 4 times 4 is 16. X to the 6 times x to the 6, the bases are the same. So it's 16x to the 12. Okay? 16x to the 12. So that's fine. Now the middle term for a minus b here, I say it's 2 times a times minus b is minus 2ab. So I'm doing the middle term for that one too. So the middle term for that one will be 2 times 4x to the 6 times minus 1, which I get as minus 8x to the 6. And then I say minus 1 times minus 1 is 1. Okay? Minus 1 squared is equal to 1. And that comprises this part in the second, well, the bit that you said you needed clarification on. So I could just write this here, all this here. I just replace it by this. Just erase this. So I just replace it by the following. Okay. I just use the a minus b squared thing there. So now I can just write it as, well, I wrote it as 16x to the 12. And then minus 8x to the 6. And plus 1, I think, yeah. Plus 1. That's how I got that. And I realized that these are like terms. So 16x to the 6 minus 8x to the 6 gives me 8x to the 6. Okay. And I retain the 16x to the 12. There's no other like term. There's no other like term for the 1, so I keep that. Okay. And by virtue of the fact that I'm dealing with a square root here, I'm aiming to write this as a complete square this here. Aiming to write it as a complete square. Okay. As a perfect square. Okay. And I managed to write it because of the factorization. I managed to write that because I know the square root of 16 is 4. The square root of x to the 6 is 12. So I get that. And I know my middle term. If I have a 4, I say 2 times 4 times 1 is 8. And I retain that exponent x to the 6. And 1 times 1 is 1. Okay. And then I just take the square root of that. And that's what it gave me. And I was hoping to make it easier for you. Hence, I wrote it in exponential form here. Okay. So that you can see the cancellation with that exponent 2.5, the exponent 6.5. But of course, I keep in mind that I'm taking square roots here all the time. Okay.
Okay. Thank you, sir.
Does that answer your question? Is that fine?
Thank you, sir. Yes.
Okay, because I was just using this here. That's all.
Thank you.
Okay, great. Okay, guys, if there are no other questions for clarification, then I was hoping you guys maybe would ask me a question that you encountered, that you're battling with, or you battled with, before I move on to the next question. Okay. Right. Okay. Can I assume then that everyone understands this problem? And let me just select the problem here. I think the one I selected, I didn't necessarily work it out prior, but I just took it because it looks interesting. Let me just say, I think there was also problem number, this was problem 73. So problem number 89 on page 43 of Stewart's Stewart's pre-calculus 6th edition. it was page 43, number 89, yeah. They say rationalize the numerator. This problem here, problem 89. They say rationalize the numerator. Some people use a Z, the Americans, the English use an S, okay? Then we write rationalize the numerator. So the problem looks like this. It says square root of x minus square root of x plus h divided by h square root x, h times square root x times the square root of x plus h. So they say rationalize the numerator, okay? So let's see how we'll approach this problem quickly. Let's see quickly. Right. So when we rationalize the numerator, well, we have to rationalize the top part of the fraction, okay? We have to rationalize this here. All right, so let me write this down. And I just want to hear from you guys what you propose. How do I start? So I'm writing that down. Okay, and I'm writing this down, h squared root x square root x plus h. Should I write down the problem correctly? So that's fine, yeah. Okay, so what do I have to multiply this with on the right-hand side?
We have to multiply by the numerator.
Yeah, but now remember we're rationalizing the numerator, okay? So you're right to a certain extent, but not totally right, okay? So I need to check with you with what we will multiply this here. Do you agree that I have to say plus?
Yes, the conjugate.
Yes, the conjugate, yeah. Yeah, that's the term that escapes me, the conjugate. I have to multiply by the conjugate, okay? And again, of course, ultimately I multiply by 1 because if I divide what I wrote down now, I just get 1, right? So I'm not changing anything here. Any number multiplied by 1 is just that number. I mean, what I've multiplied here is the number 1, right? That thing is equal to 1. So I didn't change anything there. I'm just rationalizing the numerator, okay? So what is the square root of x times the square root of x, people? I'm multiplying now, right? I'm multiplying now. So the square root of x times the square root of x. People, you know the square root of x is x to a half, right? Times x to a half. Well, the bases are the same. So I add the exponents. Equal to x. Half plus half is 1, so it's x to the 1. So if you say square root of x times square root of x, the answer is just x, okay? So you'll have x. So it's equal to x, right? Just write it nicer. Right, so square root of x times square root of x is x. There's the x. And the middle term, you will see that the middle term will cancel, okay? It's a bit like if I say to you a minus b times a plus b, you will just say a squared minus b squared. That's all. You won't even bother with the middle term because the middle term will cancel, okay? The same that happens here for our multiplication on top. I'm multiplying the top part of those two fractions, okay? So that's the same approach that I'm adopting here. Let's see. Let's just see quickly. So I've gotten rid of the square root of x. It's x, huh? Middle terms will cancel. Now I'm multiplying this here with that. And I must be careful that there's a minus sign also I have to consider. And you'll agree that it's just the same thing that I'm multiplying with it. Square root times square root. So I'll just have So that I will just have, now you must be careful, I'll have minus x plus h because of that negative sign, okay? Right, if the square root of x times the square root of x is equal to x, surely the square root of x plus h and the square root of x plus h must also give me x plus h, okay, for the same reason. So I've got my numerator sorted. Let's just see what happens in the denominator now. Let's see what happens in the denominator now. So there I've got one term here. This is one term. I must multiply it by the two terms in here. So I'm first going to multiply this here by square root of x. First going to multiply it by square root of x. So this is what I'm going to do. H square root of x, square root of x plus h, times the square root of x here. Right, and then I say plus. Now I multiply this here. I multiply by the square root of x plus h here. So I say h square root x, square root x plus h, times the square root of x plus h. This one here, I've just multiplied it now. So that's where I am. Okay. Right. So that ultimately remember there's a plus there. Plus comes from this plus here. Then ultimately I have on top, well, if I resolve those, if I sort out the brackets there, you'll see the x will cancel there. I'll have a minus h in the numerator. Okay. Now I have to look at what happens in my denominator now. There are a lot of things happening there. Well, square root of x times square root of x is x. With hx times square root of x plus h plus. Here I've got the square root of x plus h times square root of x plus h. So I've got h times the square root of x times x plus h. That's what I've left there. And my common factor, as you guys can see, my common factor is h. H arises in the numerator and also in the two terms in the denominator. So that ultimately, I take out the h. Okay, I have the minus one there. Factorize it. I factorize it here in the denominator. Well, I'll have x. Well, I can keep it like that. There's no harm, but I'll have this. Right. I'm taking h out as a common factor, guys. Okay. Let me just use a curly bracket here. Because this may cause confusion with the square root. Use a curly bracket. Okay. Now I take the h out here. And I'm left with square root of x times x plus h. Now you can see that this h cancels the h. In the final analysis, I'm left with minus 1 over that I have left in the denominator, okay, which is just x times square root x plus h plus square root x times x plus h. There's nothing else you can really do there. So you just have to let it be. Any further work is just a waste of time on that. Just write this nicely here, guys. What was this? X plus h. There's your final result, guys. So I recognize that in the numerator here, I've got h. In the denominator, h appears twice here. So I take it out as a common factor, and then I cancel it. So my final answer is, let's write this nicely here. It's minus 1 over all that, okay? Right, guys. Are you guys fine? You need further clarification regarding that? I think the part that may be confusing is this, but I'm sure I've explained it. Like that the square root of a number times the square root of a number is just a number. As you can see here, I just use the laws of exponents here to show you the truth of that. The fact that the square root of a times the square root of a is just a. So what I want to say and stress again, people, feel free to ask me any other questions that you're battling with. If you worked ahead of the pack, it's fine. It's not a problem there. It's actually good. It's fine. If someone needs clarification on earlier work, that's also fine. Nothing wrong with that too. So I don't mind any other questions, guys, that you feel that you need clarification on. Okay. So let me just go on to the next problem. I think I've selected this problem number 100 on page 43 of Stewart's book. Okay. Let me just see number 100. So I think it's a simple question. They just say that state whether the given equation is true for all values of the variables. Disregard any value that makes the denominator 0. So they say, let me just write down what they gave here. 1 plus x plus x squared divided by x equal to 1 over x plus 1 plus x. So the question here is, you must state whether this given equality, whether this equation is true for all values of the variables, if this is really true. And then they say disregard any value that makes the denominator 0. So for example, we're not considering x. Of course, guys, we can see that x cannot be equal to 0 here, because we don't allow division by 0, right? Here also x cannot be equal to 0, because you don't say a number divided by 0, right? So to make this equation consistent and logical and have meaning, we do not assume that x is equal to 0. Okay, right. So what we'll do first, guys, we can first check the left-hand side. Well, we've already simplified that as far as possible, but we can also do the following. We can do the following. I'll probably work on the right-hand side and see if I can get it to the left-hand side. Okay. So of course, there are a number of ways you can do this. So let me consider the right-hand side quickly. Just look at the right-hand side. Let's see what the right-hand side says. So the LCD there is x. I've got 1 plus x squared, which is equal to the left-hand side, okay? So that, of course, that equation will be true then. The right-hand side clearly is equal to the left-hand side. The LCD was x there, this x here. And x divides into x once. 1 times 1 is 1. Here it's 1 divided by 1. 1 divides into x. X times 1 on top is equal to x. It's x over 1. 1 divides into x. X times x is x squared, okay? So it's equal to the left-hand side, you can see. So, of course, that equation is true for all values of x. Of course, it doesn't make sense if x is equal to 0. We can't talk of that in that sense, okay? That's why they say disregard any value that makes the denominator 0. Let's look at, there's another one that they're giving. There's this one. It's an interesting one also. Let's just see quickly, guys. Let's just see. They say it's number 98. Number 98, yeah. So we must check whether this is true. X over x times x plus y, x over x plus y equal to 1 over 1 plus y. If you look at that equation, guys, is that equality true? Would you agree with that? For all values of the variables, is that true? Is the left-hand side equal to the right-hand side? for all values of x and y. Is that a fact? Someone may say yes, because if I say, someone may incorrectly say, yeah, but it's true, x divided by x is 1. I might say x divided by x is 1, but of course you can't do such divisions. It's not permissible, okay? You can't do that. And to show you that this is false, I can select any value of x and y and show you that therefore the equality cannot hold. If I choose x, say I choose x equal to 1, say, and I choose y, say, equal to, well, let me choose x equal to 2. Yeah, let me choose x equal to 2, say. Let x equal to 2, just to show that it's not true. Choose x equal to 2, and I choose y equal to, say, 3. Let's see. If I choose it like that, well, the left-hand side is equal to 2 over 2 plus 3, which is equal to 2 over 5, right? 2 over 5. The right-hand side, well, it's 1 over 1, and I chose the value of y to be 3. So it's 1 over 4, which is not equal to 2 over 5. So that equality does not hold for all values of x and y, okay? I've just constructed two values, x equal to 2, y equal to 3, and I showed you that that cannot be true for every value, okay? It may be true for some values. If I choose x equal to 1, this will be true, all right? If I choose x equal to 1, let's see what would happen. I choose x1, and I can choose y, any other value. Y can be any other value. Let y be a is some real number. Then the left-hand side will be equal to 1 over 1 plus a. A is a real number, right? Any real number. On the right-hand side, on the other side, the right-hand side, we'll have 1, the side here, over 1 plus a. So in that case, it's correct, but it's not true for all values of x and y, as I've just shown here. Okay, so you just provide a counterexample, and then show that, of course, by virtue of that, equality cannot hold for all values of x and y. Here, I just showed a particular case where it's true, but here I showed a case where it's not true. Therefore, it cannot be true in general. This equality is not true in general. It's true for the case where x is equal to 1 and y is any real number. Okay. Right, guys. Any other questions there, guys? Before I proceed to the, I think I wanted to look at some examples also and go through it with you. I think there's some examples from the book, page 52. It deals with, I think it deals with equations. Yeah, it deals with equations on page 52. So I was thinking of going through maybe 2-3 examples and then go on to inequalities, discuss inequalities briefly, and maybe do a few problems with that on that. And then entertain any other questions if there are questions, guys, okay? Right. People, can I assume that you're being quiet, is that you understand what I'm doing and that you don't have any other questions? Because I was hoping you would have some questions for me also. Okay, thanks, Makotso. Maybe I must ask people by name now, but there are 17 participants in total. So, Simpuri, are you fine with that? Are there any other pressing questions that you have?
At the moment, I'm fine. But my issue is modeling with equations. But,
okay.
Yeah, it's the only issue that I have.
Okay. Was there a particular problem that you had? Any particular problem that you're asking? See here. Yeah, okay, I see the modeling with equations. But was there a particular problem maybe? Because you reduce these things to word problems ultimately, right? Reduce it to word, it becomes a word problem. So they say modeling with equations, because later on with calculus, they will also come up with what we call differential type of equations, where they model a particular physical situation, okay? So I think they're just setting you up for those kinds of questions. But Sipue, is there any particular problem that you wanted to look at?
The thing is, on the textbook, it's quite easy. The examples are straightforward, but then, hey, when you're doing the exercises now,
okay, can you give me a particular exercise that you want us to look at? Particular one.
Okay, can I quickly check it?
Just check it for me, yeah. Then I can maybe just go on. While you check that, I can just go on with an example from page 52, an equation involving a radical, okay? So what I suggest, if we get your problem, then we'll go on in the meantime with it. And then when we're done, you can ask the question. Is that okay?
Oh yeah, that's okay.
That's fine. Okay, you let us know, but we'll go on in the meantime. So this relates to the solution of inequalities, and this particular example, it's an example from your textbook. And this example asks you to solve this equation here. It asks you to solve that. Okay. I know radicals are always a tricky thing. So what we propose here is the following. We just square everything here in this case. To get rid of radicals, what you do now, you just square. So I square the left-hand side because it's an equation. What I do on the left, I do on the right. I square everything inside there. Right? I square. Even the -1 gets squared. Okay. And I told you before that square root of x is equal to x. Okay. Right. So that your left-hand side is now 4x squared, and multiply out that bracket, minus 4x plus 1. And on the right-hand side, I even square the -1. -1 times -1 is 1. So then I'm left with that positive. This becomes a positive 1. This here. Negative becomes a positive 1. And then under the third, well, if I multiply by the same number, the third, same number, well, I just get a number. So that ultimately, I'll just end up with 2 minus x. The minus x, right? So that ultimately now you can aim at factorizing the following, because now you just say 4x squared. And when you take the x across to the left, or you add x to the right-hand side, you subtract 2 on the right-hand side, you do the same on the left-hand side, so that you'll have minus 3x, and you'll have minus 1 equal to 0 now. So I've just transposed those terms, right? So that ultimately when you factorize, this is what you get. It's 4x plus 1 and x minus 1. For this to be true, well, means that 4x plus 1 equal to 0, or x minus 1 is equal to 0. So looking at this one here, for that to be 0, it means that x must be minus a quarter. And for this one here, x equal to 1. And then you can check whether, you can go back to your original equation and check whether these numbers really satisfy that equality here. Okay? So let's first try x equal to 1 and see what happens there. Let's try x equal to 1 quickly. We can start with anyone, it doesn't matter here. Let's look at the left-hand side. Let's look at x equal to 1 and see if it's indeed a solution to this equality here, right? So let's see. Let's look at x equal to 1. Let's look at the left-hand side. Well, the left-hand side is 2 times 1 minus 1, which is equal to 1. And the right-hand side, well, we substitute it's minus square root of 2 minus 1, which is minus 1, which means that the left and right-hand side are not the same, right? So here for this case, x equal to 1, the left and right-hand sides are not the same. So x equal to 1 is not a solution. Now let's check x equal to a quarter and see what happens on the left-hand side. Well, for the left-hand side, we've got 2 times a quarter is minus a quarter, né? Minus a quarter, sorry. 2 times minus a quarter, minus 1. Well, it's minus a half, minus 1. It's minus 3 over 2. And the right-hand side, check the right-hand side now. Right-hand side, it's minus 2 times, minus square root of 2 minus there. Minus 2 minus, and x is minus a quarter. Let's see there. It's minus. So inside I've got 2 plus a quarter, which is 9 over 4. Which is 2 and a quarter, which is 9 over 4. And you know that the square root of 9 is 3 and the square root of 4 is 2. So clearly for this case, the left-hand side and the right-hand sides, they are equal. So the only solution here is the solution x equal to minus a quarter. Okay, right. So with thirds, try and do just square things on the left and the right. Try and square those, and then hopefully things will fall out nicely, and then you can double check whatever solution you come up with if it is indeed a legitimate solution. Okay. Okay, Sibu, I trust that you managed to find your problem. Let me just check, guys. Did you follow the reasoning for this problem on equalities with surds?
Sir, may you please repeat on the negative that is on the right-hand side?
For the negative a quarter, negative a quarter?
No, sir. Your step number 1.
Yeah, but I'm asking for the case x equal to minus a quarter, for that case.
Yes, sir.
Okay, okay, right. On the right hand side, okay. Okay, so let me start afresh. So for the right hand side, remember the right hand side looks like this, né? Right? So now I substitute in here. I substitute x equal to minus a quarter. Okay, minus. So it's, I say 2 minus, it's minus a quarter. Right? So 2 plus a quarter, right? Well, 2 plus a quarter, well, my LCD there is 4. This is 2 over 1, this is 1 over 4. 1 goes into 4, 4 times 2 is 8. Plus 4 goes into 4 once, 1 times 1 is 1. Minus 9 over 4. And the square root of 9 is 3, and the square root of 4 is 2. Okay, that's it. Is that clear?
Yes, sir.
Okay, great.
How do you remove the negative that is up there on the
What
step
about,
number?
what about the negative? Are you talking about here? You're talking about the negative?
Yes, sir. The negative that is on the right-hand side.
Oh, this negative, yeah. This one there?
Yes, sir. But when you start at the top there.
Oh, okay. Oh yeah. Oh, when I did when I squared things, when I squared it. You're talking about that? When I did this, yeah.
Yes, sir. Please, how did you remove that negative?
Okay, how did I get rid of the negative? Yeah.
Yes, sir.
Okay, so remember I squared the left-hand side and I squared the right-hand side. So if I say to you, for example, minus a squared, some real number a minus a squared, okay? Well, I have to square. This is negative 1 times a. What is negative 1 times negative 1? 1, right? And a times a is a squared. But 1 times a squared is a squared. You see that? So this is this is negative 1. And negative 1 squared is 1. And a times a is a squared. And a squared times 1 is a squared. See that? So that's how I got rid of this negative. But what I do in the final analysis, when I check my answers, my roots that I found, I must go back to the original equation. And then I must consider the negative now. Because now I'm checking whether these solutions are legitimate, are mathematically legitimate solutions. Okay? If it will satisfy this equality. So then now I go back to my original, I keep my negative there. Okay? The removal of the negative, we were aiming to remove the surds so they can end up with some quadratic equation, some sort, okay? When we square the left, we square the right, but everything on the right must be squared. This is one term on the right, so we can, so minus 1 is a factor there, square root square root 2 minus x is a factor, but it's one term on the right. So when I square the right-hand side, I square everything that's there, okay? Even the minus 1.
Yes, sir.
Is that fine?
Yes, sir.
Okay, great. Okay, so I think if there are no other questions, then we can just proceed to CPUA, perhaps. Yeah.
Oh, okay. I found the question.
Okay.
It's on the study guide.
Oh, on the study guide. Okay, okay.
Yeah.
Fine. So this is a question on mathematical modeling, guys. So, okay, can you give me the question there? Let me call it exercise. Okay. It's from the exercises, you're saying that? Okay,
Yes.
great. Great, okay.
Okay, can I read the whole thing?
Yes, yes.
Okay, it says a salesman drives from IX to Barrington.
A salesman?
A salesman.
Oh, a salesman.
Yeah, drives from IX to Barrington.
Drives from A to B.
Yes,
from A
yeah.
to B. Okay.
A distance of 120 miles.
A distance.
At a steady speed.
Distance of 120 miles at
a steady speed.
At a constant speed. Eh?
Yes.
Constant speed, okay?
He then He then increases his speed by 10 miles per hour.
Okay, he then increases speed by 10 miles per hour.
To drive the 150 miles from Barrington to Collins.
Drive the 150 miles from B to C in another place, no?
Yes.
Yeah. Okay.
And then it says, if the second leg of his trip took 6 minutes more time than the first leg.
The trip from B to C. If the trip from B to C, no?
Yeah.
It's the second leg. The trip from B to C, the second leg, right? From B to C. Took
6 minutes more time than the first leg.
6 minutes more time than from A to B time. Then from A to B.
Yes. And then the question says, how fast was he driving between IX and Barrington?
Okay. Okay. How fast was he driving from A to B?
Yes.
From A to B, right? Good.
Yes.
Okay, let's think about this. This is a nice one. A salesman, so let's write your solution. Okay, great. So let's be logical about this, right? A salesman drives from A to B a distance of 120 miles, right? At a constant speed. So we do not know that speed, right? Constant speed. So let's say A to B, let X be the speed. Let X be the speed, okay? Between A and B, we don't know, right? We know it's a constant speed, right? The distance, Y, let X be the speed, let Y, distance of 120 miles. So we're given the distance there. So we don't need to, so the distance Y, let me just say, let Y equal to 120 be distance, right? Be the distance between A and B, right? Salesman drives from A to B a distance of 120 miles. So the distance between A and B is 120 miles, right? At constant speed. This is for A to B. It's fine. Let X be the speed for A to B, and let Y equal to 120 miles be the distance, right? Okay. Right. He then increases the speed. So after B, just when he goes past B, he increases the speed by 10 miles per hour, right? So now he increases the speed by 10 miles per hour. So the speed was X, right? Then increases it. The speed was X between A and B. Then increases now between B and C. He increases the speed. Speed increases to X plus 10. Remember, it was X, it increased by 10, right? So the new speed, this is the new speed between B and C, X plus 10. Right, so increased, right? To drive the 150 miles from B to C. And the distance from B to C, I can call this distance Y1, and this distance from B to C, I can call it Y2. Y2 is equal to 150 miles per 150 miles, okay? Right. To drive 150 miles. If the trip from B to C took, what was this? Took 6 minutes more, right? So the time now, right? Time is 6 minutes more, right? Then from A to B. How fast was he driving from A to B? Can you see that? So the time is more. If the time between, so let the time here be T. Between A and B, let T equal the time taken. T is the time taken. Time is 6 minutes more. So the time from B to C, time from B to C is T plus 6. Can you see that, guys? Okay. But of course, here we speak of hours and minutes. So we'll have to convert everything now to one standard. I think what we'll have to do, they speak of miles in terms of distance, right? They speak of miles per hour in terms of speed. So what we'll have to do now, we'll have to change this time. This 6 minutes here, we must change it to hours now to be consistent with that. So this is T plus 6 minutes, but it won't make sense for us to work like that. What is 6 minutes of 1 hour, guys? What is 6 minutes of 1 hour? 1/10, eh? It's 1/10 of an hour. Do you agree with me, guys? 0.1 hours, right? So the time actually time in hours was t plus 0,1. Okay, because we have to be consistent with our units. Here the distance is miles here, 120 miles. Here the distance, here the speed increased by 10 miles per hour, so that's okay. That's fine, it's consistent there. Here the distance is 150 miles. Now they say the time taken between B and C is 6 minutes more, which is 0,1 hour more. This is the time between B and C, okay? Right. So if we can find T, then we're okay. The question was, how fast was he driving from A to B, right? We need to find X. How fast was he driving from A to B? Let X be the speed between A and B. Y1 is 120. T is the time taken, right? So let's see now. So distance for A to B. From A to B, let's see. So the distance is speed multiplied by time, because this is a constant speed, right? So distance is equal to speed multiplied by time. Okay, we've got that. We do not have the time. We do not have the speed. We have the distance though, right? Then from B to C, well, he drove 150 miles. And again, it is speed. But what was the speed now? The speed increased to 10 miles more, 10 miles per hour more. And the time now that it took is 6 minutes more, but now we converted 6 to 0,1 hours. That's 6 minutes, okay? So there's your two equations to solve. You've got two equations, you've got two unknowns. You've got X and T as unknowns. You can solve those equations now. You can substitute one and express it in terms of the other. You can find now, you'll be able now to find how fast was he driving from A to B. If you find X, you have solved the problem. If you found X, you solved the problem, right? So the unknown, let X be the speed between A and B. Let Y1 be 120 is the distance, and T the time taken. It's a constant speed. Distance is speed multiplied by time. When it goes from B to C, it's a distance of 150 miles. But now it drives 10 miles per hour more. Faster. The speed increased by 10. So okay, the new speed is X plus 10, right? And the time it took now, it took 6 minutes more, but then it's 0,1 hour. So it's the time taken between A to B plus 6 minutes. There's it. Any questions there, guys? Any questions? Are you fine with that approach?
Yeah, so far.
You're happy with the fact that now I have made sure that I work in hours and miles, né? Hours and miles per hour, right? You understand that? Because you can't keep 6 minutes then talk of time in terms of hours. You understand that?
Yes.
Okay, so remember we need to find X. Let X be the speed between A and B. The question asks, how fast was it driving from A to B? So we need to find X, okay, the speed between A and B. The two equations, two unknowns. I'll call this one here equation 1. I'll call this one equation 2. We need to find X, right? So what I propose is the following. Let's see quickly. If I write T in terms of X, then it's solved. Oh, the problem is solved, basically. Okay, right. So from equation 1, we have the following. Time is equal to 120 divided by X. Are you happy with that, guys?
Yes.
Right. Now I'll substitute. I'll call this equation 3. I will substitute 3 into 2 now. I'll substitute equation 3 into equation 2 now. So what do I have? Then I have 150 equal to x plus 10, right? Now, what is my time now? What is t now here?
120 over x.
120 over x plus 0, 0.1. 0.1 is 1/10, 1 over 10, right? People, if I write 0.1, I can just write 1 over 10. You agree with me? I don't need a calculator, right? Are you happy with that, guys? 0.1 is 1/10. Okay, good. Right, now, thus, now I'm going to multiply out and see what I have, because I've got one variable in one equation now. So now I'm going to do my usual multiplications, which I know you guys know. I'm going to multiply this bracket here for this bracket there. Okay, everything in there. So see if you agree with me. I'm just going to write now. I'm not going to say anything. I'm just going to write, okay? You agree with my multiplications there, guys?
Yes, sir.
Yes.
Good, good. All right, you've checked. No mistakes, no? No mistakes there. So what I did for the guys who are a bit lost, maybe I said x times 120 over x. Okay, x is cancelled and left with 120. Then I said x times 1 over 10, it's x over 10. Then I said 10 times 120 over x, 1,200 over x. Then I said 10 times 1 over 10, it's 1. Okay? So you see, now, what I will do now, I will get my LCD, my lowest common denominator on the right-hand side, which is 10x. This is x over 10 here, right? The lowest common denominator is 10x. I'm looking at these four terms on the right-hand side, okay? Now, this is 120 over 1. 1 goes in there, 10x. It's 1,200x. Oh, guys, just not to belabor things too much. Not to belabor things too much, let me do this. There are constants there that I can add. There are constants that I can add there, okay? What is 120 plus 1? 120? 1. 120 plus 1 is 121. Sorry, guys, I just neglected that. Otherwise, you'll have a lot of unnecessary terms that you could have gotten rid of, okay? If you guys are fine, then we can proceed then, okay? So let's just get the LCD. Sorry, guys, let's just get the LCD there. Say it's 10x. 121 over 1, right? Goes in there. 1 goes in there, 10x, 10x times that, it's 1210x. Right? So I multiplied 121 by 10. I just add a 0 there and x, okay? And then 10 goes in 10x x times, I've got x squared. And then the x cancels there. X goes in 10x, well, 10 times. And here I've got 12,000, okay? Because I multiplied by 10. You must just double check my calculations, guys. Do I trust that you're with me there? Right? Then I can do a so-called cross multiplication. Sorry, Simple?
I'm saying, yeah, I'm with you.
Okay, great. Now I'm going to do a cross multiplication. And I will take my terms now. I will have 0. I will transpose the 1,500 to the right-hand side. Okay. And I will add it to this here, 1210, because I will have the following now. Minus 15x plus 1210x plus x squared plus 2,000. Right? And then, of course, there are like terms. the like terms here, and we know what happens there. So I'll have 290x minus 290x. Just double check again.
Yeah, it's correct.
Okay.
Is it supposed to be 12,000?
12,000. Why am I writing that? Thanks. Thanks. Sorry, guys. Sorry. Yeah, it's 12,000, right? I wrote it down and then I changed it. Sorry for that. Good. Okay. Are you happy with the calculations thus far? Thanks for that. You're fine with that. Just double check. Just double check these two here, guys. Did I add correctly there?
Yeah, that's correct.
Correct. Eh? Okay. So now I'm just going to rearrange stuff to make it more familiar with you guys. And you can see that you end up with a quadratic equation. Of course, x cannot be a negative because we don't speak of negative distance. We speak of negative displacement as a vector, but x is a distance, a scalar. So distance is either greater or equal to 0. It's never negative, okay? Unless you do some physics, then you speak of displacement in a negative sense, meaning direction, okay? But we don't worry about that here. What did I have here? X squared. Right. And now you can solve that. Well, there's no cancellation happening here. You can use the quadratic formula if you want to. I'm just thinking 40 times 30, 400 times 30. I'm trying to break this 12,000 up now because I'm aiming to get this now, but I don't see how I can do it. 60 times 20. 60 times 200. Yeah, I will use the quadratic formula now. X equal to minus b plus or minus the square root of b squared minus 4ac over 2a. I don't see how it can factorize nicely, Simple. I'm not sure if you've tried it. I can't think quick enough. There was a 300 there. Let's just see what happens. Okay, guys. So can you guys see that A is 1, B is minus 290, and C is 12,000, right? Remember, guys, when you solve AX squared plus BX plus C equal to 0, and you don't expect some nice factoring happening, you use the quadratic formula. So for us, A in here is 1. It's the coefficient of X squared, right? B for us is minus 290. And C is equal to 12,000. So now you do the substitution, minus B. So it's minus 290 plus or minus the square root of B squared. What is B squared there? Minus 290 squared. So I think here they allow for calculators because it's modeling, right? Here they would allow for calculators because with mathematical modeling, they're normally what they call numerical work. Okay, so minus 4. A is 1. C is minus. C is 12,000. I think they will permit calculator here. All divided by 2. Right. So you have 290 plus or minus that ugly bit, and you guys can use your calculators now. What is 290 times 290, guys? Because there's a negative squared, right? So it's positive. What is 290 times 290? Oh yeah, I've got 48,000.
84,100.
Just 84,000?
100.
100. And on the right, I've got 48,000, right? Divided by 2. Right. I'll divide by 2. So you have 290 plus or minus. What is this now? 48,000. What is that? 46,100. What is it? 46,100?
36,100.
36,100. 36,100. No?
100, yes.
Okay, great. 6,000. 100. Okay, can you now give me your final answer there? You'll have two answers there. Thus, remember, this x is the speed. We call it the speed. Thus, x is equal to that, or x is equal to that. What is the square root of 36,000, guys?
Huh? 660.
Huh?
It's 60 or 660. Just thinking.
But
Just
60
thinking, lady.
190.
Yeah, because 60 times 60 is 3,600, so it can't be that, right? So he says it's 190. Just confirm there, guys, with me. If 36,100, I'm looking for the square root of 36,100, guys, okay? 36,100 plus or minus that, right? 290 plus or minus that. I don't have a calculator. Let me just use the phone quickly. Just use the phone quickly, guys. Where's this calculator? Where's my calculator on this one? I never use this. Where's this? Sorry, guys. Let me just try and find the proper calculator.
190. 190.
The calculator now. Yes, I found it. Okay, I'll tell you now, guys. I managed to get hold of the calculator. Right. So I get 290 plus that, so the square root of 36,100. I'm getting is 190. Good, 190. So 190 plus 290. So I'm taking the positive part. 190 plus 290. Right, it's 480. Divide by 2. Then I get the one value for x. I get the one value 480 miles per hour, which is a bit big, massive. 480 miles per hour. On the other end, if I say 290 minus 190, I get 100. Divide by 2, which is 50 miles per hour. 50 miles per hour. Just double check this calculation here, guys.
Isn't the first one supposed to be 240 miles per hour?
I'm supposed to divide still, no? I'm supposed to divide. 290 plus 190 is 480. Divide by 2 is 240. Thanks for that, Sipu. This is 240, guys. I didn't divide by 2, okay? 240, né? Which is quite massive. And then just double check for me this one, guys. 290 minus 190, it's 100. Divide by 2, it's 50 miles per hour, okay? So now we have to decide which one of these is the correct one now, okay? Right, let's see. But do you agree with the second calculation also there, guys?
Yes, it's correct.
50 miles there. So x is either 240 miles per hour or x is 50 miles per hour. Let's check which one. Let's check which one will give us, which one makes sense. I'm not sure, simply if you got an answer from where you worked from. Is there an answer to that thing? Simply.
So am I supposed to substitute one of the two answers?
Yeah, you know, but you see, then the one will, because yeah, you're supposed to check it now, verify it, because you don't know which one is the right one. You got two answers. It's a quadratic equation, right? It's a quadratic equation, so you have to check now. So I'm looking at, I'm trying to be logical here. I'm trying to be logical. So the distance was 120 miles from A to B, and if he drove, and if he took from A to B, remember this is the speed between A and B here. It's 240 miles, right? The distance was 120, so he drove half an hour. Can you see that? means that he drove 30 minutes between A and B, right? Or if he drove at this speed, it took 30 minutes between A and B. If he drove this speed between A and B, well, 50 divides into 120. Well, then it took 2.4 hours, okay? 2.4 hours it took. Because now you'll have to go back and find the time now also. Because you have X now, so you can also find the time. You see that? Also find the time now because you express the time in terms of that. Look here. Here you've got an equation for time. Time is 120 over X. Can you see that? You have an equation for time, 120 over X. So if the speed was 240, then it took him half an hour. If the speed was 50, it took him 2.4 hours. Can you see that? Okay. You understand? Okay. Can you guys hear me? I was just cut out a bit, Shemaya. Okay, Sibuya, can you hear me?
Yeah, yes, I can.
Network.
Yeah, yes, the network there. Yeah. You have two answers. You have two possibilities. It's either the distance between A and the speed between A and B was miles per hour, or the speed was 50 miles per hour. You have to decide what is the right one now. Check it. Okay. Now you remember that we express time in terms of X as follows. We expressed it like this from equation 1. We set up equation 1, and we found time was 120 divided by X, right? So we found that time. Now what we can do now is to substitute and check. Although we expect some consistency with question 2, we can now get the time for 240 from here. Remember this equation here, guys? T is 120 over X. Then we can test those answers and check how it relates to the other. So T is 120 over X. Now we can substitute X equal to, let's say we use X, say X equal to 240. We're checking X equal to 240 now. So therefore, T is 120 over 240, right? Which is equal to a half, which is 0.5 hours, right? Which is 30 minutes. This is 30 minutes, right? That if this person drove between A and B 240 miles per hour, it took him half an hour to get there, right? Right. But now let's check how it relates to equation number 3 now. If that is correct, let's check how this will satisfy equation 3, because it must satisfy both equations simultaneously. Sorry, let's see how it satisfies equation. I'm putting X there, and we put T a half here. I'm going to put X 240 here and T a half, right? So it's X plus 10 times T plus 0.1. Let's just see. So the other equation 2 was 150 equal to X plus 10 times T plus 0.1. So now I'm testing those values now. So I'm using 240 for X plus 10. And T, for T, I'm using the T I found here, 0.5. plus 0.1. Can you guys multiply that out and see if I get the right answer? So 250. And that gives you 150, right?
Yes, it does.
You see 50 miles. Let's see when x was 50 miles. There were two answers, 50 and 240. Now we're checking x 50 miles per hour, right? The time now, well, the time, I use the same equation, t is equal to 120 over x. Now I say 2.4 hours, right? Can you guys see the whiteboard? 2.4 hours. Can you see that? So when he drove 50 miles per hour between A and B, distance of 120, took him 2.4 hours, right? Right. Now let's check it in this equation. If this equation holds, let's check it now. Okay, so 150. Two comma 4 or 0.1. I suspect that both will hold in that case. So 60 to 150. So there are two possible speeds that it traveled and of course two corresponding times, okay, that will satisfy that equation. So both of those solutions are possible solutions. Can you see that, guys? 60 times 2.5, it's 120 plus 30 is 150. Yeah. So both of those solutions they said. I'm not sure, Simple, if you got answers to those questions. I'm not sure. Okay.
Yes, I did, and thank you very much because your approach is much
What
more
are those answers?
It's 150. Both the distance is 150. When I substitute, yeah, they're consistent. Okay. Yeah, they are both correct. They both seem to be correct. Yes,
I've double checked. Both equalities are satisfied. Equation 2 satisfied, and yeah, it's just logical. The corresponding time. If he drove at a speed of 240 miles per hour, it took him half an hour between A and B. On the other end, if he drove at a speed of 50 miles per hour, it would take him 2.4 hours. Okay, great. Okay. So in that case, guys, both solutions apply. Just a longer time and lesser speed, longer time, greater speed, shorter time. Okay, right. Great. Thanks, Simple. Thanks for that question. That was a good one. Okay.
Right. Yeah, thank you very much for clarifying it.
No problem. Okay, so you can see how these modeling with equations, how it helps you to solve such problems. Now, you guys will encounter when you do the calculus, you'll do a lot of differentiation and stuff, and use the methods of differentiation and techniques to solve problems relating to maxima and minima, optimizations, those kinds of problems, rates of change, and these kinds of problems that you ask, rates of change problems, okay? Right. Okay, guys, are there any other further nice questions like Simpue's ones? Did you guys have problems with? Maybe in another section, perhaps? I think this 3-hour session is a bit too long for me. And I'm getting a bit bored with my voice. So if there are no other questions, we can perhaps look at maybe 1 or 2 more stuff from equations. I think that question of Simpue covers a lot of issues and how you think about a problem. And I trust that everyone else is okay with the approach. I hope I didn't confuse people too much with the approach, but I tried to be as simple as possible, okay? So what I would do then, if I wanted to proceed, I wanted to go on with with page 53, look at an example there involving fractional powers, etc. Look at the fourth degree equation of quadratic type, maybe something like that. I was looking at stuff like that. Okay. Yeah. Otherwise, we can maybe, where's Mrs. Prim, is she around? Shumaya? Shumaya? Okay. Let me just try and get hold of it, guys. People, I just want to, I feel like I just want to stop the session here, and then when we meet again, I want us to go on with inequalities if possible. Start with a new section, inequalities, and finish it off, okay? And any other questions, like maybe someone who works ahead or someone is a bit behind, any other questions for clarification, that's also fine, okay? So I was just hoping you guys would come up with more questions, and then I will prepare a bit better for inequalities and hopefully also some aspects of chapter 2 relating to functions, okay? So I think the 3-hour session is a bit hectic, but I'll see if we can maintain this, and hopefully, but I'll try and arrange a session for, because next weekend I won't be available, so I'll try and arrange a 2-hour session for Wednesday next week, if it's okay with you guys, maybe 4:30 to 6:30. I'll speak to Ms. Prim. But I think let's just stop there. And then unless there are other questions, other pressing questions that you have, I can look at those. And I just wanted to check with Ms. Prim if we can stop there. And then we can just go on with section 1.7. And probably section, I think chapter 2 also. Okay. So can I gather from you guys if there are any other questions there? Shadrach, any other questions?
So can you please solve a trigonomic identity for me?
Oh, okay. Let me just answer this quickly from Ms. Pram. Okay, the trigonometric identity, great, no problem. You'll give me the problem and I'll write it down, right? Okay, Shmaya, no, it's fine, Shmaya. I'm just gonna go on for the next half an hour or so, right? And then I'll stop, okay? Is that fine? Yeah. Yes. No, I won't leave yet. I will leave maybe in half an hour's time. They just wanted to have some.
Thank you so much, students. If I can ask you just to please check. Can you hear me? Are you able to hear me?
Yes, ma'am.
Wonderful, wonderful. Students, these classes is offered to students for academic support. However, the continuation of these classes to ensure that we have these classes is based on your evaluation. So what you think of the benefits of the class to you, that is important to UNISA. And so our lecturers evaluate that. So for every workshop that we have, these students need to complete an evaluation form. Now, don't panic. It takes you it'll probably take you about 30 seconds to complete. It's online. All you need to do, click, and submit. So if you just click on the link, it's just 30 seconds and you submit, and that's that. So please do that so that we can ensure that these classes continue.
Okay, Ms. Pram. So
thank you.
So Ms. Pram, so they have some questions. Fortunately, some of them have some more questions. So I'll probably be at it for around half an hour or so. Okay.
All right. Thank you so much.
Okay, but I see some have questions now. I'm happy about that. So someone asked the question, someone wants to ask a question on trigonometric identities. That's great. I'm happy about that. Okay. Awesome. So can you just check with you guys? Do you guys still see the whiteboard? Do you still see the whiteboard there?
Yes.
I want to write. Okay, great. So I want to write down that question. If everyone is happy with Simpu's question and you understood that and the solution, then I want to entertain the student who wants to ask a question. I want to give her a platform. And just read me the question on trigonometric identities then, okay? Right. Okay, can I have that question? I'll just call it exercise, okay? Exercise. Let me just call it exercise.
It's
okay.
10:45 degrees.
Sorry?
10:45. It's 10:45.
At 10:45. Sorry?
Okay, the equation is
10 or 10
45.
10:45 degrees, okay?
CSC.
Hmm.
In brackets 180 plus.
So must I bracket it now? Must I bracket it now? 180. Right?
Plus.
Right? Plus.
Angle and then close the bracket cot.
But angle theta. Is it theta?
Yes.
Theta. And then times cot.
Minus angle theta in brackets.
Minus theta.
Close
right?
Brackets plus cos 90 plus theta.
Okay. Okay. Let me just right. Is this correct what I wrote down here? It doesn't seem right what I wrote down here.
It is.
Just is that how they wrote it?
Yes.
10:45. 10:45. Is it just like that? Wow. Okay.
It keeps going though.
Okay. Oh,
Plus,
oh, it keeps going, eh?
Yes.
Okay, okay. So am I right? You cot negative theta and then what?
Plus cos 90
Plus
cos in brackets 90 plus theta.
90 plus theta.
Close the bracket, sine 180 plus theta.
Sine 180 plus theta.
All over.
Okay, let me just do this nicer here. I didn't write the theta so nicely. Okay, all divide by. Let me just do this nicer. I can do better than that. Sorry for that, guys. Sorry for that. I did a larger eraser. Yeah. Okay, great. Sorry for that. Let me just do this nicer. All divide by?
Sec 30 degrees.
Sec 30 degrees.
10 in brackets theta minus 180.
So sec 30 degrees, 10.
Theta minus 180 degrees.
Theta minus 180 degrees.
And then close the bracket. CSC squared.
Sorry?
CSC squared.
CSC cosec.
Yes.
Squared.
In brackets 180 minus theta.
180 degrees minus theta.
And then you're supposed to prove that it's equal to the square root of 3 cos theta.
Square root of 3.
Cos theta.
Theta was the long thing.
And
I need
then
space. I need
open
space.
Brackets.
Okay, let me see. I'm going to show that it's equal to square root of 3 cos
theta.
Theta.
So why did you open a bracket? You're not supposed to open a bracket.
Oh, I was sort of anticipating something because I've been doing brackets all the time with you. So okay.
And then in brackets cos theta plus
cos theta plus?
No. It's cos theta, right? And then in brackets,
Okay.
cos theta plus sine to the power 4 theta.
The sine to the
Power 4 theta.
theta.
Oh, and then it's all over 2.
Okay. So is there anything missing in the denominator?
It's 2 sine theta.
2 sine.
Theta.
So are you happy with everything I wrote down there? Is that
Yes.
okay?
And then at the top, sir, it's tan 45 and then cosec before the 180.
That's what I suspect. I was still looking at this. I was still staring at this. It didn't make sense to me. So it's 1045. Just bear with me. 1045. Okay, and you said what was here? Cosec.
Cosec.
Yeah, that's what I was grappling with. Cosec. Okay, great stuff. No problem. That's fine. So okay. So let me say. So are you sure everything is correct there now? Everything's correct, eh?
Yes, sir.
Great. So make sure that we don't have anything, and then we'll solve this nicely. So the approach will be so she says 1045 times cosec 180. And then is there something happening here? Perhaps it's missing here. Just check here. That's something. I suspect there's something missing there too.
Oh yeah, it's cos.
Cos, no?
Yes.
Okay, so let me just bear with me. I just need to erase this then and write everything, okay? So you'll need to call it out for me again, okay? So yeah, so you say it's cos, okay?
90 plus theta.
90 degrees plus theta, okay?
And then multiply by sine 180
Sine.
plus theta.
Sine 180 plus theta. Great. Was that all, no? Was that it? Okay.
Yes.
So 1045. Well, that's 1 over the square root of 2. 1045 is 1, right? 1045 is 1. Sorry, 1045 is 1. Cosec 180 plus that. So that's in the third. That's in the third quadrant. Cot minus theta is in the fourth. Cot that angle is in the fourth quadrant. Plus is in the sine 180 plus. It's in the third quadrant. So sec that first quadrant. Theta minus 180. So you sure about this also? Okay. Can you guys hear me? Hello?
Yes.
Right, okay. I
Yes.
think I was out again for a minute, not well, for a few seconds again. Let me just see, guys. Guys, where do you propose? Where do we start with this problem now? I need to hear from you guys. Do we start with do we start with this side, or do we start with this side? Which side do we start with?
At the top.
Yes, we start with the top one. That makes more sense because it has a lot of. I mean, you can work. This is a simple form. This one here, simple form. The second question mark at the bottom, right? So you'll obviously you've got this fractional type at the top. That's the one where we start. Okay, and it assumes certain things that you know of these functions, of these trigonometric functions in the. Guys, okay, I was out again. Sorry, you can still see the whiteboard, right? This is bad. Okay, right. So what we'll do, guys, we'll look at that. She says everything is fine now. She's checked it. So cos theta is fine. Sine to the 4 theta, that's fine. So there's no problem, right? Okay. So here, the supposition is that you will not use calculators here, guys. No calculators, okay? You will use even for stuff like 1045. And I hope you guys have written the problem down, right? So then when I go up and I write, and everything's fine. So let's look at 45 and the tan of 45. Just from your special angles, okay? There's 45 degrees. There's 45 degrees. It's 1 square root of 2. Tan is opposite over adjacent. So clearly, from your special angles, the tan of 45 here is equal to 1. Right? Tan of 45 degrees without a calculator, just using your special angles, the theorem of Pythagoras, the tan of 45 is 1. Are we fine with it, guys? Do you agree with me? Just looking at this right angle triangle here, right? Okay.
Yes.
Good. Now, let's look at the next factor there, cosec 180 plus theta. So cosec and sine are what we call multiplicative inverses, okay? They're not inverses in the sense of f inverse x is equal to x, not in that sense, okay? So here they are just multiplicative inverses. So if I say to you the sine of something, let's say is a half, the sine of an angle is a half, the cosec is 2, okay? If I say to you the sine of an angle is 1/3, the cosec of that angle is 3. You understand that? Because cosec theta is 1 over sine theta. Sine theta is 1 over cosec theta. You guys know that, right? And with cot theta is 1 over tan theta, and tan theta, okay, right. So they are multiplicative inverses. You understand it? Reciprocals, okay? The reciprocal functions, but not inverse in the sense that we talk of later on. Okay, not in that sense. Then I'm just going through them as they stand there, and then the sec of theta. The sec of theta is 1 over cos theta, and the cos of theta is 1 over sec theta. That's all what you must know. Okay, those are important observations there, so it will help us deal with this on top here. Now let's look at. So if we've dealt with tan 45, it's 1. Let's look at cosec 180 plus theta. Cosec 180 plus theta, right? Let's look at that. To make it easier, I can rewrite everything actually in a nicer way and stick to stuff that's familiar to you guys. I stick with stuff that's familiar to you, okay? It's not a problem, we can do that. So what I'm going to do is I'm going to take everything just to make things easier for you. I'm going to rewrite everything. For example, you see this cosec here, I will write it in the denominator as sine 180 plus theta. Okay, this cot here, I will write it in the denominator as tan minus theta. This sec here, I will rewrite it in the numerator as cos 30. Right? I will do something to this one. I will leave it there, but I will play around with it. And this cosec squared here, I will write it in the numerator as sine squared 180 minus theta. Do you agree with that approach, guys? Do you understand why I do it? Right? By virtue of what I said here. See that? Okay. So let me call this the left-hand side, right? Let me call this the left-hand side. Call this the left-hand side. So now, based on what I said, this is what I'm going to do. And sorry guys, I'll just flip up and down. The left-hand side is equal to, right? Now I'll write it down. Tan 45, I said to you it's 1. You agreed with me. I'm writing it down, okay? Let me draw that line now right through. Tan 45 is 1. This one is sorted. This cosec, I'm going to write it in the denominator as sine, because sine and cosec are multiplicative inverses. They are reciprocal functions, right? So I'm going to write cosec as sine 180 plus theta. That's what I'm doing there, okay? So that you're familiar. So I'm cool, we're cool with that one, it's dealt with, okay? I've dealt with that one. I've dealt with that one. Now let's look at cot. Cot Well, in the denominator, it will be 10 minus theta. Right? So I've dealt with 10. I've dealt with cot. Now it says plus. That was multiplications that I was doing there. Now it says plus. So I only have the 1 here. I only have the 1 here. So let me just use this. Just write 1. All those other things went to the denominator. So 1040. The rest, I have put them in the denominator. Okay. This was cosec 180 plus theta in the numerator. This cot minus theta in the numerator. Now it says plus. Now I'm here now, plus. Does this cos 90 plus theta? I will keep it like that. Why is what I did in the denominator not correct? Something that I did that was not correct, yeah. It's a simple thing. I just need to do 1 or 2 things and things will be fine. But I missed something. Let me do this for you. Okay. I'll explain you now why I couldn't do that. People 1045 is 1, right? This cosec is 1 over sine. This cot is 1 over 10. So I couldn't just drop it to the denominator like that, this denominator here. Couldn't just drop it to there. But I can write it as 1 over that. This is the 10. This on top is sec. This is cot on top. Okay. But I'll still have another layer here of fractions here. I'll have another layer of fractions here in the denominator. Okay. I'll have another section there. So to write it like this, okay? Cos 90 plus cos 90 plus theta, that's fine. Plus cos 90 degrees plus theta, that's okay. Just extend there, that's okay. Because I'm multiplying. Oh, that cos must come here. Must come here. Just come here. Plus, sorry for that, guys, cos 90 degrees plus theta. And then next to that one, stand sine 180 plus theta. Times sine 180 plus theta. Okay, great. Right. Are you happy with what I wrote down there, guys, and the way I wrote it? Is that fine? There's 1045. There's the 1. Okay. Okay. The plus separates, this plus separates the terms. So when 1045, which is 1 indeed, I multiply by cos sec 180. I'm dividing 10 minus theta. So that's quite fine to write it like that. Then it's separated by the plus, and I've got the second that. In the denominator, I'll be careful now. What I will do is I must be very careful. This one, this fortunately one people, can you see the create some space here. I can write it as follows. You can just I can write it, guys. Just need some Do some space here.
Wait, sir, I'm lost.
I just make sure that you guys follow thus far what I've done.
Sir, I'm lost.
Point. One. That's not a problem. It's not a problem. But you need to tell me also, né? But you lost. Why you lost? Okay.
So when you're solving identities, aren't you supposed to like look at the things that you're given and then figure out which quadrant they're in, and then figure out if they're positive or negative, and then simplify from there?
Yes. No, you're correct. You're correct. But what I'm doing now, I'm trying to let me just rewrite nicely for trying familiar trigonometric and sec. So I'm trying to do that now first. Then we will deal with the quadrants. So I first want us to write things simpler, and I just want to write this just a bit smaller. So I don't want cosec and cot and sec. I don't want those things around us. It will disturb us. Okay. And then we will look at, and then we will look at, right, problem will be solved easily then. Okay. So I'm just writing things a bit smaller here, guys. And I want you to see how things will fall out nicely, okay? And I want to check with you guys whether you've done compound angles and those kinds of things also, right? So I'm writing things a bit smaller because I need to do the following. You don't worry about that. So 19 is equal to the following. All right. Guys, can you hear me?
Yes, sir, we can hear you.
Okay, great. So I'm gonna explain you now what I'm doing now. Okay. So, and I want you to think about this. 10 theta minus 180. I just need to write it small. everything that was given now. Okay. I'm gonna do it step by step with you now. I'm gonna look at this separately. And this is what I'm gonna do, guys. Okay. I want you to look at this. Let's look at this. We will just look at this part here. Tan 45, cosec 180 plus theta, cot minus theta. I'm only going to look at these three factors here. Okay, that's all I'm going to look at now, and I'm going to write it for you so that you guys agree with me. Okay. So let's look at them and see how what is okay. Right. Tan 45 degrees is equal to 1. There's the 1. Okay? From the special angles. Cosec 180 plus theta is the same as 1 over sine 180 degrees plus theta. Right? And then cot minus theta is the same as 1 over 10 minus theta. Do you agree with that, with those statements, guys? Do you agree that this is true from the special angles? Yes. Do you also agree with that? Right? Do you agree that cosec is 1 over sine? Do you agree?
Yes, sir.
That cot is 1 over 10, right? Right, 1045 is 1. There's the 1045 1. It's still on top. There's your cosec 180. There's cosec 180 plus theta. There's cot minus theta. Because of this relationship, I can write it like that. Do you agree with that? Do you understand why I've written it like that now? Well, if you agree with all these things here, guys, then you must agree with the way I wrote it down here. You must agree with what I wrote down here. If you say, no, you understand all this, then you must understand that, okay? Forget about this here now. Forget about this now and forget about that. I'll explain that now, okay? I just want to make sure that you guys understand why I wrote down what I wrote down here. 1045 is 1.
We do, sir.
This, great stuff, okay? Because of that inverse, because of that reciprocal nature. Of cosine, okay? Right, now, plus, here's the plus part. Now I'm aiming at this part. That I leave unchanged. I leave it unchanged, okay? Cos 90 plus theta, I don't have a problem with cosine. It's there. Sine 180 plus theta is there, okay? Everything is there. Right, so these ones are catered for. I don't think you have a problem with that, right? You don't have a problem with that. Great. Now, look at the denominator. Look at the denominator. I'm going to write something down for you now. Look at this denominator. Do you agree that the denominator is one term? Because it's only multiplication. It's not the factors sec, tan, and cosec are not split up by pluses, unlike this part here. It's 1. Can you see that? It's just one term, right? Do you agree that this is one term, you guys? Because it's multiplication. Yes. You agree that it's like one factor, right? One term. Well, 3 factors, one term, right? 3 factors, one term, okay? So now I write it now. That's in the denominator, right? Look how I write it up in the numerator now. And I'm going to show you by numbers now. Look where it happens now. Look, there it comes up. It's on top now. See, it's on top. Now I multiply it by what I wrote down already. I multiplied by this and by that, okay? Now, but look what I did. I shifted it up. I used the multiplicative inverse nature of it. Look here. Look here. When I split it up, it becomes cos. When I split this up, cos. When I split this, when I Well, this one, okay, this one I should stay down because it's 10. That one I can bring down. I shouldn't write it as cot. I want to bring it down. It should come down. This one. This one is sine squared. It's on top. Okay. So the only thing I'm going to remove is this one from the top side. This one is sine squared on top. This is cos on top. There they are. The only one I'm going to remove is this 10 here because it should be in the denominator. I don't want to write it as cot. I don't want to write it as cot. Okay. So this 10, I'm going to bring this closer here. The 10 will be the only one in the denominator now. The 10. Okay? It will be the only one left in the denominator. 10. You will see how it will play out, and you'll see how that equation comes to fruition. This will be the only one in the denominator, the 10. That is on top, the cos, that is on top. The 10 is the only one in the denominator. And look how I write it. 10 minus 180 degrees minus theta. Okay, just 10. Right, so the only one was supposed to stay was the 10. So if you agree with everything there, guys, we can start doing the work now, okay? So if you agree with everything what I wrote down there, start doing the work. 10 remains in the denominator. All the others, this is cos in the numerator. This is sine squared in the numerator now. Okay, so there they are. So we will deal with this thing and we'll resolve that problem. Okay, let me just check, make sure if I wrote down the 10 correctly again. There it is. Okay, it's 10 theta minus 180. I took out the negative and I wrote it down as 180 minus theta, but it's a negative angle. Okay, right. So let me just use the eraser and erase other parts here, and then we can start working on that problem now and start with the stuff that we know. Now we can look at the sign at which quadrants they are now that we agree that we've got this fraction outside and we've got the two terms inside there. Okay, right. Just some facts, guys. Just some facts quickly. What is the cos of 30 degrees? What is the cosine of 30 degrees? From the theorem of Pythagoras. Well, the cos of 30 clearly from here cos of 30, it's adjacent of hypotenuse. Square root of 3 over 2. You agree with that, guys? Cos of 30?
Yes, sir.
Yes.
Great. Okay, remember that. In fact, let me just do a partitioning of some sort here. Keep the other facts here. I just need some space. What did I do now? I don't want that. Okay, just do some sort of partitioning here. Well, I just wanted to write these facts. Why is it doing that now? Just wanted to get the facts right here. Okay, right. Now, guys, let's see. So you're happy with cos of 30, we have it. And you can see, look at that square root of 3 here in the answer. Look at that square root of 3 coming up. Look at square root of 3 over 2 coming up. It probably comes from that 30. Can you see that, guys? She says this is the right-hand side. Okay, right-hand side. Square root of 3 over 2 times all that. That's what she said. Okay. And you can see, guys, that only the answer, the right-hand side, where we're working towards this right-hand side. We're working towards this. You say, if I express all those signs as fast as possible, the tens will deal with itself. We'll cancel it probably, okay? But that's okay for now. Let's not jump the gun here. So we've dealt with the cos of 30 square root of 3 over 2. Right. Now my question is, from your high school experience, and I'm looking at this part here, what is the sine? What is the sine of 180 minus theta? And I want you to use a test value for that. Every time I want you to use a calculator and check with a specific case. I am saying the sine of 180 minus theta. This lies in the second quadrant, and in the second quadrant, sine is positive. This is equal to the sine of theta. Remember, all trigonometric functions, relations are positive. All trigonometric relations are positive in the first quadrant. Second quadrant, sine, right? Third quadrant, tan. And the fourth quadrant, cosine, okay? Of course, with sine goes cosec. They are positive in the second and first quadrant. With tan and cot, they are positive in the first and the fourth and the third quadrant. With sec, guys, from school, man. So, for example, what I want you to check for me is the following. Check the sine of 150 for me. And see that the sine of 150 is the sine of 30. Do you agree that if theta is 30 degrees, the sine of 150 is the same as sine of 30 is a half? Do you agree with that, guys?
Yes.
Yes.
Good. So I was just trying to show you that the sine of 180 minus theta is the sine of theta. That's what it means basically, okay? Right. So we can write this sine squared as sine squared theta. This one here, we can write it as sine squared theta. Okay? So let me try and add things as we go along. Cos of 30, we said it's square root of 3 over 2. Based on what we just said now, right? Let's go inside there. Let's go inside there. Now, this was 10 minus theta, right? 1 over. What is the sine of 180 plus theta? What quadrant is that? That's in the third quadrant. So I'm saying to you, you can check for me. Negative. Good. They can again use a test value. This is minus sine theta because it's in the third quadrant. Sine is negative there, right? You can use a test value. For example, you can say, check the sine of 180 degrees plus say 30 degrees. That's sine of 210 degrees. And you'll see it's minus the sine of 30, which is minus a half. So if you check the sine of 210 degrees, your answer will be minus a half. You get that, guys? Right? If you press on your calculator sine 210, which is 180 plus 30, you will see it's the same as the sine as minus the sine of 30, which is minus half. Okay? Just as a check. Okay? So as she said it's minus sine. What is the tan of minus theta? Where does minus theta lie? In the fourth quadrant. Tan is negative there. So tan of minus theta is minus tan theta. Remember, people, in the fourth quadrant, tan is negative there. This is an acute angle in the fourth quadrant. Tan of minus theta is minus the tan of theta. Okay? Right. So that's what you have there. Plus separately. Now, we know the sine of 180 plus theta is minus sine theta. We just need to check the cos of 90 plus theta. Right. The cos of 90 plus theta. What is the cos of 90 plus theta, guys?
Negative sine.
Minus?
Sine theta.
Minus sine theta. Is that what you're saying?
Yes, sir.
Good. Okay. People listen. The cos of 90 plus theta is negative sine theta. Okay? It's negative sine theta. Cos and sine are co-functions. Okay, they are co-functions. So it's like this. if you say to me, $90, the cofunctions, okay? Look, they add up nicely to 90. 60 plus 30 is 90. If you say to me cos 89 degrees is the same as sine of 1 degree, right? If you say to me sine of 45 is the same as cos 45 degrees, right? 1 over square root of 2. They are cofunctions. So if you say to me cos of 90 plus theta, there's another way of doing this. There's another way of doing this, okay? So they are cofunctions, so we say it's minus sine theta, right? They are cofunctions, right? You will see that these angles add up to 90. These angles add up to 90. So another way of thinking of this is as follows. You put a minus there. Now you say minus theta plus 90 is equal to 90 degrees. So they add up to 90. But sine of minus theta is minus the sine of theta. You can also do it like this. There is this compound angle formula at school. It says the cos of A plus B is the cos of A times the cos of B minus the sine of A times the sine of B. You would have encountered that at high school at some stage of your lives, okay? So in particular, if you say cos of 90 plus theta, well, it's cos 90. I'm using the formula here. The cos of 90 times cos of theta minus the sine of 90 sine of theta, right? And the sine of 90 is 1. So cos 90 plus theta is minus the sine of theta. Okay, for this reason and for the reasons I've given here. Okay, right. So we have this one here. We've dealt with this case here. It's minus the sine of theta plus minus the sine of theta. Right, this part here. The sine of 180 plus theta, she said it's minus sine theta also in the third quadrant. Right, now I'm left with what's left here. The tan of minus 180 minus theta. Okay, tan of minus 180 minus theta. Okay, let's see quickly. Well, there are many ways to resolve this part here. Well, if you look at tan 180 minus theta, let's look at the tan of 180 minus theta. Oh, let me just note, people, you will see how I wrote this here. I've just written this in another form here. Let's look at the original problem. And I rewrote it like this. That's all. Okay, same thing. But if you look at the tan, if you look at the tan of 180 minus theta, what is the tan of 180 minus theta, guys? It's in the second quadrant, so it's minus tan theta, right? Do you agree with that, guys? Are you guys happy with that?
Yes.
Yeah, because it's in quadrant 2, tan is negative. In quadrant 2, tan is negative there, right? That's the reason for that. So, what do you think now will be the tan of I'm just looking at some formulas for tan. So I'm trying to derive it in another way for you guys. So those are compound formula for tan also. Yeah. There's a compound formula for tan also from high school. If you can't figure that out, then you can just derive it also, okay? Let me just see how I can derive that one. I'm just looking for a compound formula. 10. For 10, 180 minus theta. You can write it as follows, okay? Or for for theta minus 180, you can write it as follows. I'm just going to write it down for you. There's a 10 formula that says the following. It says that 10x plus y, 10x minus y, sorry. Let's say 10x minus y, right? It says the following, 10x minus y. 10x minus y is 10x plus 10y, 10x minus 10y, over, then it's 1 plus 10x 10y, 1 plus 10x 10y. Now, we had a case, in our case, it was, we were given initially, and I rewrote it for you guys. We were given 10 theta minus 180. Remember, I took out the negative and rewrote it, okay? So in terms of this formula, I can write it as 10 theta minus 10 180, right? Divided by 1 plus 10 theta 10 180, right? Now, if you look at the graph of the 10 function, how does it behave? It's got a very odd behavior, right? A very odd behavior between minus 90 and 90. It goes something like that. Then it goes something like that again. What is the 10 of 180, guys? You know it's 0, right? 10 of 180 degrees from that graph. 10 of 180, it's equal to 0 from the graph, okay, that I've just drawn there. Remember, the way I drew the graph here, here was 0. This was minus 90 degrees. This was 90 degrees. This was 180 degrees here. So it's actually 0 there. This is the x-axis or the theta axis. This is the y-axis here. So 10 180 is 0. So if I substitute back into this formula for 10, I've got 10 theta. 10 180 is 0 over 10 180 is 0, so this whole thing is 0. So the 10 of theta minus 180 is the 10 of theta. 10 of theta minus 180 is the 10 of theta. And it brings me back to this point here that I made, that if I introduce the minus, well, this thing becomes a plus now, 10 of theta. So there's that case. I've shown you two ways now that the 10 of theta minus 180 or the 10 of minus 180 minus theta, in brackets, is the 10 of theta. Okay, right. So that ultimately, we can write this whole thing as follows, and it should give us that solution that we require. So this here is the 10 of theta. Right. Let me use the big eraser to erase those things. And then we can start proving that formula, okay? Right. Let's get rid of these quickly, guys, then we finish now. Now we'll check whether this is equal to the right-hand side. It's square root of 3 over 2 thing. Right. Let's see, guys. Why am I not moving now? Why can't I move up? Right. So, guys, this is how far we came. Remember, we need the right-hand side to be equal to the following. Square root of 3 over 2 On top, we've got cos theta times cos theta plus sine squared, sine to the 4 theta, divided by, well, it's sine theta there. That's what we must have, okay? Remember, this is our answer. Our answer must be this, square root of 3 over 2, top cos theta times cos theta plus sine to the 4 theta, and the denominator 2 sine theta. Let's just see. So we need to get rid of the stains and stuff, okay? Right, so let's do the following. Let's do the following here. Square root 3 over 2. And then I've got sine there, okay, sine squared. I've got my tan there. Outside. It's outside, all that is outside. Inside, I've got 1 over sine theta. Negative times a negative is a positive. Now I get my lowest common denominator for the inside bracket. I get my lowest common denominator for the inside bracket. Tan theta. Sorry, guys. So that's sine theta, tan theta. It's 1 plus sine cubed theta, tan theta. Right. Okay, great.
Can the two tan theta be rewritten as 2 sine over cos?
Yes, it can. It can. Yeah, it can. There's no problem with that. That's fine. Okay. So let's do that quickly and get rid of stuff quickly then. Thanks for that. So what she proposes, guys, we can do it immediately. She says this is sine squared theta. In the denominator, sorry, in the numerator, in the denominator, where is this? There is no. Oh, okay, sine squared theta. But tan is sine over cos. Sine over cos. With sine theta over cos theta. I just wanted to avoid the duplication of things, and I first want to do the multiplication out and then do some cancellations. That's what I wanted to do initially, okay? But it's no problem. And then this is sine theta over cos theta, right? Can you see that, guys? It's sine over cos. Right, so you can write it like that, and then the sign cancels there, and so on and so on. But for now, I just want us to leave this part a bit. I don't want it, it looks complicated. I want to leave this for the end, okay? Let's see here now what happens here. I hope I'm not just repeating things because I'll multiply. Let me multiply out now. Let's multiply out now. I think it's okay now because we have got one term there. People, what I'm going to do now, I'm going to leave the square root of 3 to outside. I'm going to leave it outside. I'm going to multiply this. I'm going to multiply this by what's inside there, okay? I'm going to multiply this what's inside there. So this is what I'm going to do. I'm going to say sine squared theta. And then I'm multiplying it with a sine to the 5 theta, tan theta. The denominator, I multiply sine theta times tan squared theta. Okay. I know tan theta, I know it, it's sine squared over cos squared, okay? Sine squared over cos squared, so it's not a problem there. That's not a problem there, okay? Now we should get closer to that thing, and I can take out sine if I wanted. I could have kept the sine out and just keep one sine, and then sine to the 4 will be there. I just need to be reminded of that equality. Take out a common factor. Just take out a common factor. Are you guys happy with the multiplications there, guys? Happy with the multiplications? I can take sine out as a common factor here, okay? Take sine out as a common factor. And then do some cancellations there, okay? So what I can do, you can take sine out as a common factor and do some cancellations. Can you see that? Guys, no? Just use this eraser here. Take sine out. Inside there, sine is a common factor. Inside sine is a common factor there, okay? Sine theta, I can take it out, and I'm left with sine theta plus sine to the 4, tan theta. So I've taken out the sine, and that after this sine here, I can put it there. Inside here, I'm left with tan squared theta. I just need to be reminded, what is that right-hand side again? Because I have to go back and forth on top. So I've got a cancellation there. And then when you rework this, you should get to that thing. You should be able to get to that. Because now I will do some stuff very quickly. And I will, I know there was a sine to the 4 somewhere in there. I just can't remember. I probably need another.
It was the square root of 3.
Okay.
It was the square root of 3 cos theta.
Cos theta, right?
Cos theta plus 4 sine to the power 4 theta. And then all divided by 2 sine theta.
All divided by sine 2 theta. Oh, okay. Okay, so, so why? Let me just see, I need to write it down and use another whiteboard again. Now it doesn't seem to want to go. Okay, oh, it was like this then. Let me write it down, the paste page, and then work towards that. Okay, so I don't want to have convoluted stuff. Square root of 32, cos theta, right? Cos theta again, plus sine to the 4 theta. So we got rid of some stuff there. And then in the denominator, we got sine theta. Okay, because that tan is cos over sine. So let me just remind myself. Sine to the 4 there. Sine to the 4. But I just need to remind what I need to end up with, okay? Need to remind myself. There's that sine to the 4, there's it. Okay, that's cool. So we should get there in the next half a minute or so. Ms. Prim wasn't in the session. I just hope.
Yes, I'm sorry, Dr.
Yes, yeah. I just need to finish this problem quickly, Ms. Prim. So you won't end the session yet, please. Then. Thanks. Sorry for that. Sorry, I didn't.
Not a problem. I'll wait for you to finish.
Yes, I had to explain a lot of preliminary stuff, and then before we could get to this. So now, we've got that scenario, right? Let's look at the 10 in the denominator now. Let's look at the 10 in the denominator, okay? And this is what I'm gonna do, and I want you guys to catch it quickly. 10 squared theta is sine squared theta over cos squared theta. Do you agree with that, guys? Because 10 is cos sine over cos, right? Therefore, 10 squared is sine squared over cos squared, right? Is everyone happy with that? Can everyone see that 10 squared is sine squared over cos? Because 10 is, remember guys, 10 is sine over cos, right? Yeah, good. Okay, so look what I'm going to do now. Look what I'm going to do carefully now. I'm going to replace 10 squared theta with sine squared over cos squared, and the cos squared will go to the numerator. And the sine squared will be in the denominator. That's what will happen now, okay? Yeah, I need to deal with this thing here also. I also need to deal with this thing here. Just need to get rid of something here. I'm thinking of a way to do it nicely without, because I need that sign also. Yes, and that sign is there. There's the sine squared. There's my 1 over 10 squared in the denominator. Taken care of it. There's it. Here's it. Remember, it's in the denominator, so if I want to write it back in the standard form, I must write it like that. I must take the reciprocal of that, right? And this here, so I've gotten rid of that. I've gotten rid of that 10 squared. Here's the 10 squared, cos squared over sine squared. Now, I must be wary that I should have this 10 is sine over cos. Sine over cos. Okay, sine over cos. Right. Sine over cos. So I need a cos there. I need a cos there. If I multiply that, that cancels with that cos. I have a cos, yeah. Okay. There's it. Sine squared. Let's do all those multiplications and see what's going to happen now, guys, in terms of sine and cos. I'm going to do all those multiplications now and see what falls out, okay? So this is what I'm going to do. I'm going to say cos squared theta. I'm just multiplying now. I'm just multiplying now. I'm multiplying out now. Do you understand what I did now, guys? I multiplied cos squared in there with everything there, okay? And it canceled the cos squared here. Can you see that? Cancel the cos squared in there. The cos theta there. Remember that 10, I rewrote it as sine over cos. I'm talking about this part here. Now I multiply this cos squared with everything, it cancels it. I'm left with cos theta and sine to the 5. Okay? Here I multiplied the denominator by that. My common factor is sine theta. My common factor is sine theta again, which I take out and it cancels, right? And I can also take out a cos theta there. I'm taking out cos theta. And I'm taking out sine theta. I'm going to cancel sine theta. I'm taking out cos theta. I'm going to cancel sine theta. Okay? There's a sine here. And there's a sine to the 5 there. I'm going to make it sine to 4. And this one's going to only have a sine there. I'm going to do the cancellations. In fact, let me do it like this. Take out cos. I've got cos. Sine. I cancel it in the denominator. I've got sine there. Let me take it out nicely for you guys slowly. Take it out nicely for you guys. So I took out sine. Let me also take out, sine and cos again. Not sine and cos again. There's your final answer that you wanted, guys. There's your answer, guys. Okay. Right. So what I did here, this the step before that, I realized that sine comes up and cos comes up in the numerator. I took it out, sine theta, cos theta, because I'm aiming at the right-hand side. I took it out, and then I'm left with cos theta when it goes in there, sine is canceling that one. And then here, I took out the sine, so I'm sine to the 4, and I took out the cosine. And the denominator, well, I cancel the sine there, cancel the sine with the sine squared there, and I'm left with that. And there's the answer that you want, guys. Okay? Does that answer your question then?
Yes, sir. Thank you.
Okay. Look, I had to discuss the preliminary stuff first before I could delve into that. I could write it down and show you the connection between cot and tan and cosec and sine again and sec and cos. Because you can see that in the final answer on the right-hand side, nothing appears in terms of tan, cot, nor cos, nor sec. Can you see that? There's no sec there. There's no cos there. There's no cosec there. There's no cot there. So I had to change those things, which looked a bit awkward at the beginning, but it was necessary to do that. And then you deal with the quadrants. And then I had to remind you of some relationships that exist for compound angles and stuff, but you can also get it without that. So that's why initially I rewrote everything into this funny form here, okay? Left-hand side, because I just wanted to make sure that there are no cots, no secs, no cosecs, nothing like that, okay? No functions like those secant functions, the cosecant functions, those co-functions. I wanted to get rid of them, okay? And also, in fact, get rid of the reciprocal functions and write the standard reciprocal functions, okay? That's all. So this was the first step of the problem. This was the first step, rewriting things like this, and then checking the quadrant. And then I had to resort to some identities and stuff that you know from these things. I had to use those things, but never did use a calculator, okay? Okay, guys. Then I'll try and see. I won't see you next Saturday, but I'll try and see you in the weekend, guys, okay? Thanks, no?
Thank you, sir.
Okay,
Thank
great.
you, sir.
I'm sorry about the length of it, but that's the best I could do. And I think if anyone were to explain you this, they have to go through those things, okay? Okay, thanks, guys. I'll see you again then. Keep well.